Welcome back to my channel, Maths Made Easy. Today, let's begin Arithmetic Progression Part 1. Arithmetic Progression. So, do you know what is arithmetic progression? Okay, let me tell you. A sequence in which the difference between two consecutive terms is same throughout is called an arithmetic sequence or an arithmetic progression. Let me give you two more definitions. Then through an example, I will try to clear the definition. So, a sequence in which the difference between a term and its previous term is same throughout is called an arithmetic sequence or an arithmetic progression. One more definition. A sequence in which the difference between a term and its preceding term. Remember, preceding term means previous term. They have same meaning. So, a sequence in which the difference between a term and its preceding term is same throughout is called an arithmetic sequence or an arithmetic progression. Now let me give an example. So I have a sequence of 2, 4, 6, 8, 10, tn minus 1, tn. If I try to find a difference between a term and its preceding term, let me take the difference of 4 and 2. The difference of 4 and 2 is 2. Similarly, the difference of 6 and 4 is again 2. The difference of 8 and 6 is also 2. Similarly, the difference of 10 and 8 is how much? Of course 2. Means the difference is coming same throughout. No matter whichever two consecutive terms we take, the difference is coming same. Same 2. So we can say it is a constant. The difference between any two terms is a constant. It does not change. For example, 4 minus 2 is 2. Can 6 minus 4 be 3? No. 6 minus 4 is also 2. 8 minus 6 is also 2. Means the same constant difference is coming. So if we try to find out the difference of last two terms, that is tn minus 1, it must also come 2. It must not come 3, 4, 5 or any other number. If it comes any other number, then this sequence is not an AP. Is this clear? So always keep one thing in mind. To prove any sequence as an AP, we will show the difference of tn and tn minus 1. Means a term and its previous term as constant. That is tn minus 1 is constant. Let me clear this through an example. Question number 1. A sequence is given by tn equal to 2n minus 3. Find whether the given sequence is an AP or not. We have learned a sequence is said to be an AP if the difference between two consecutive terms is same throughout. Isn't that? So we will try to prove the difference between two consecutive terms is same throughout in this case. And this note, as mentioned earlier, to prove any sequence as an AP, we will prove tn minus 1 as constant. So solution here given is tn equal to 2n minus 3. We will replace this n and this n by n minus 1. So replacing n by n minus 1, we will get tn minus 1 is equal to 2 in bracket n minus 1 minus 3. We will simplify this right hand side to ultimately get 2n minus 5. Now we have obtained tn minus 1. Means both these are present now. Now we will find their difference. So to find the difference, we will subtract 2 from 1. So subtracting 2 from 1, we will get this line. Remember, left hand side must be subtracted from left hand side and right hand side must be subtracted from right hand side. And since we are subtracting, we must keep a bracket over here because minus changes the sign. Then we will open the bracket in right hand side, simplify to ultimately get 2. This 2 is a constant. Here is absence of any and. The symbol and is not present over here. Means no matter whatever is the value of n in left hand side, the right hand side will always come 2. Let's say n is equal to 5. Then t5 minus t, how much? 4. Because 5 minus 1 is 4. We have taken n as 5. So 5 minus 1 is 4. So t5 minus t4 is 2. Let's take 2 more examples. N equal to 7. Then t7 minus t6 is again 2. Let's say n is equal to 11. Then t11 minus t10 is again 2. Means we are getting the difference between two terms, two consecutive terms, or a term and its preceding term, or a term and its previous term as same 2. So which is constant and is free from n. So no matter whatever is the value of n, we will get difference between two consecutive terms as always a constant. Hence the sequence given by Tn equal to 2n minus 3 is an AP. Now this is another way of doing the same question. The same question was in previous page. So in this case, what we do is we replace this n by n plus 1. In previous case, we replaced n by n minus 1. But now here we are replacing n by n plus 1. Remaining all the process is same, just n is replaced by n plus 1. And one more thing you must keep in mind that in previous case we subtracted 2 from 1. But here we are subtracting 1 from 2. Why? Because we need a difference between a term and its preceding term. Of course, the preceding term of Tn plus 1 is Tn. Is this clear? And lastly, one note. Every sequence given by a linear expression is an AP. I hope you know the meaning of linear expression. We have learned an expression is said to be linear if the highest power of the variable is 1. In this case, the variable is n. The highest power of n is 1 over here. So it is a linear expression. Similarly, in this case, the variable is n and the highest power of n is 1. So this is also a linear expression. In our question, this is also a linear expression. Linear expression always gives an AP, arithmetic progression. And next note, you must keep in mind that the common difference will be the coefficient of n. In this case, the coefficient of n is 2. So the common difference of the sequence given by this expression will be 2. Similarly, the common difference in this case will be 9. In our case, the common difference is 2. This is a common difference. It is 2 and 2 is the coefficient of n. I hope this is clear to you.